Hi students. So in today's video we will see the design and implementation of your full adder. So first we have to start on with your design of your full adder. So what is your full adder? It performs the addition of two binary bits and along with your carry bit something called Cin. So this is a variable we are going to make use of to denote your carry bit Cin. So along with the binary bits A and B, the third bit we call it as a Cin. It is going to perform your addition. So three bits are going to be added. What is your final sum and carry out? So this is what we are going to analyze today. So already we know that what are the two bits? The possible combinations of your two bits are 0, 0, 0, 1, 1, 0, 1, 1. Suppose with these two input bits, if when I am adding a series of addition or performing series of addition, a previous carry would be generated. So if that is either 0 or 1, what would be the final sum and carry? So that is what we are going to diagnose, and based on that only we are going to plot the truth table of your full adder. So that function, the logical function which performs the addition over the three bits. What are those three bits? Your two normal binary bits A and B, or the actual binary input bit along with the previous carry generated input Cin. We call it as a carry Cin. That is your previous carry. And along with that, if it performs the addition, what is my final sum and final carry? Say suppose for an example, because this is a circuit designed by an engineer predicting what would my circuit do when this kind of or this set of inputs arises. So having that in mind, we have to analyze and design. So as you all know, truth table is nothing but it represents your function, logical function of your circuit. So suppose if for this case, so I am going to analyze case by case. Here we have four cases. For the four cases, if the previous carry generated is either 0 or 1, what is my output? So that is what your full adder. So if the two bits, say suppose for the case 0, 0, if my previous carry is 0, what is my sum and what is my carry? Say suppose this is your 0, 0, inputs are. What is my sum? As you all know already, 0 plus 0, my sum is 0, carry generated would also be 0 at that time. Wherein, suppose along with this set of inputs, if my previous carry generated is 0 now, what will happen? That bit would be always added with the sum bit. So this is the bit. What is the status of the bit? Here it is 0. So 0 plus 0, again it is sum. What is that? Sum is 0. My carry is also 0. So sum is 0, carry is 0. So that you have to plot it here. Suppose for the same case, when the inputs are 0, 0, if the previous generated carry bit is 1, what would be the final output? Because as you all know, when both the inputs are added and finally if it is added with 0, now I am getting 0. Got it? If the previous carry generated is 1 now, then 0 plus 1 would be what? 1. So which would be changed? The sum bit. So if the previous carry generated is 1 now, so 0 plus 1 would be 1, where the sum bit would be 1. Whether the carry would be generated? No. So still it is 0. Did you get it what I am trying to say? So first it performs, always a circuit performs the addition of A and B. That sum output would be added with the previous carry. And finally the sum bit would be changed. Got it? So for next case we will analyze. Just a moment. For the next case, when the inputs are 0 and 1, what is my sum and carry? So when the inputs are 0 and 1, what would be the addition? Simply speaking, 0 plus 1 is what? Sum is 1, carry out is 0. If my previous generated carry is 0 now, again it will perform the addition. 0 plus 1 is what? 1. So there is no change. So it will be 1 and carry out will be 0. Say suppose for the case, same case 0, 1. What will be the addition? 0 plus 1 is what? Initially it will be 1, carry out will be 0. Suppose the previous carry generated is 1. What will happen? It will perform the addition between these two. So 1 plus 1 will, what will happen? It will change the bit to carry bit would be generated and this would be changed to 0.